Hi everyone, this is Dr. Sandeep, working as Associate Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to discuss about the properties of materials. So generally properties means the different types of material will have different types of properties. So how these properties are differentiated, we will see in this today's session. So these properties vary physically as well as the mechanically. So there is a lot of difference between the physical properties as well as the mechanical properties. So what is the difference between the physical properties as well as the mechanical properties? So physical means physically the appearance of any material. Okay, like the length of the material or the size of the material or the different geometry of the material. So this is the physical appearance of any given material, which is calculated with the help of some scales. Okay, if you measure the quantity of any type of material, this comes under the physical property of the material. Now coming to the mechanical property of the material. So if any load is applied on the material, so there is some stress developed inside the body. So how to calculate, so how the body is being deforming due to the application of the load will describe the mechanical properties. So that is the difference between the physical as well as the mechanical properties. So the physical is the measurable quantity. So if you see the definition of the physical property, what is it telling? Physical properties are the things which are measurable. So we are measuring the length or the width, okay, or the dimensions of any given material will describe the physical appearance of the material. So that's why it is called as a physical property. And these are the like densities, melting point, conductivity, coefficient of expansion. So all these comes under the physical properties. So physically how these are being conducting into the material, how the heat is being conducting into the element, so that is a physical property. And how the material is being elongated, so that is also a physical quantity. So these are all the measurable. So how much amount of there is change inside the body, okay, that gives the physical property of the material. So which are measurable quantities, these are called as a physical. Now coming to the mechanical, so what is happening here? The performance of the material. So when you apply any different types of forces or different types of forces on the material, so what is the performance of the material? So how these material is withstanding to that? So what is the strength of the material? So what is the ductility, wear resistance? So these are some of the examples of the mechanical properties, how the material is being responding. Okay, so different types of compressive load or tensile load you are applying on the material, how the body is responding to those loads will describe the mechanical properties. So that is the difference between the properties. So once if you want to develop any product, so if you have to know the exact properties. So these properties plays a key role in developing any product. So if you know the correct or exact properties, then it is very easy for us to select any type of material, okay, to the required application. So any application, if you want to develop any product, so first of all you have to know the properties. Once you know the mechanical and physical properties, then it is very easy for us to select some from X to Z components. One exact component you will select, and that component it can be used as an application to the developed product. So that is how these physical as well as the mechanical properties plays an important role in selecting of any material in developing any product. So the mechanical as well as the physical properties of materials are determined by their chemical composition. So the chemical compositions are also very, very important. So different materials will have its own composition. So depending upon the carbon content, that is the iron content of the material. So these materials are being classified as ferrous and non-ferrous materials. So in some applications, you may need ferrous types of materials. So how to identify the ferrous material? The composition is very, very important. So how much amount of iron is content inside the material? So if you have the larger quantity of iron present inside the material, then it is called as a ferrous materials. And so in the same case, if you have the less amount of carbon or the iron content, So that those are called as a non-ferrous. So the composition again plays an important role to differentiate the types of materials and also their internal structure. So in the previous sessions, we have discussed about the different types of structures, the face-centered, body-centered, hexagonal, face-centered structures. So all these structures also help us to identify the how the atoms are arranged inside the body. Depending upon the atom arrangement, we can easily tell the properties or the mechanical properties of the material, and also the grain size or the crystal structure. So depending upon the size of the grain present inside the material also plays an important role, and the arrangement of each grain inside the material also plays an important role. So if any molecule is diverting inside the composition of the material, what happens? There is some disturbance in the material. So uniformity has to be maintained. So that's why not only the physical as well as the mechanical properties are very much important. In this case also the structure, the grain size as well as the composition also very important. So all these combined helps us to identify the exact material for developing any type of product. So that's why these points plays an important role for doing any type of product development in applications. Next, mechanical properties may be greatly affect the processing due to the rearrangement of internal structure. So one we have an X material, so this is having a good properties. Now the same material, if you want to enhance the mechanical properties, what you will do? You do the heat treatment process. So one can change the mechanical properties by heat treatment process. So in this heat treatment process, what we can do, if any irregularities are there, what are the defects are there inside the material, can be regularized, can be normalized by the help of the heat treatment process. So once you heat the material, so again what temperature you have to heat? So again you have to know the property. So what is the melting point of the material, you have to know. Once if you know the melting point of the material, you have to heat the material below that melting point. If you cross the melting point, what happens? The solid form converts into liquid form. So that's why always any material has to be preheated, or it has to be done heat treatment until it reaches to its recrystallization temperature. So after recrystallization temperature, when the metal is being reached, there you can do any changes of the mechanical properties. You can add any other material, like you can build up a composite material, or if any defects are there, you can normalize those defects by heating. Why? Because any molecules are not equally distributed. This, after doing the heat treatment process, what are the molecules are there, they may come into an equal level. So that is called as a normalizing. So that is one of the point. And of course, the what are the full point defect, line defect, any type of defect can be normalized with the help of preheat process. That's why the mechanical properties can greatly affected or greatly changed by the processing due to the rearrangement of the internal structure. So whatever arrangement is there internally, if you try to rearrange this structure inside the material, so what is happening? There is a chances of enhancement of the properties of the mechanical properties of the material. And also metalworking process or heat treatment process might play a significant role. So as we discussed, the heat treatment process is very important, and it's playing a significant role in changing the properties of any type of material. Any type of material. Suppose I have to build up a product with some ceramic material or some polymeric material. So this polymeric material doesn't have that standards of the properties what I am thinking. So what can I do? I can enhance the properties of that material by adding some other material to it. Okay, so this is called as a composite. So how can I add? I can't directly add the other material to the other material. A and B I can't combine together. So how can I combine and I can enhance the mechanical properties or any chemical properties? I can do this performance by heat treatment process or metalworking. So in this metalworking as well as the heat treatment process, what I can do, I'll heat the material. So once I heat the material, I can do any number of changes into the material. I can add the material, any other material, or I can do any manufacturing different types of shapes I can do. So all these things can be achieved That's why the metalworking process or the heat treatment process plays a significant role in affecting some of the physical properties. So what are those physical properties we can see, like density, the conductivity? So these are the main things which can be enhanced or can be changed with the help of these heat treatment process. And also the mechanical properties as well as the physical properties plays a determination in which alloys are considered for suitable application. So that's why once if you know the application, depending upon the application only we will select the material. So directly we can't select the material and we can do the production. No, once if you know the application, then only you can select the material. Again, how to select the material? Once if you know the properties, all the properties, that's why the properties are very important. Once if you know the physical as well as the mechanical properties of any material, okay, that is very easy for us to select the material for the required application. Suppose if you take a tea glass. So if you know the application of the tea glass, if it doesn't know the application of tea glass, what you will do? If I prepare with an iron, so I can't drink with the iron metal. Okay, ceramic material is the best choice for cup of tea, making the tea glass. So that's why if you know the application of the products which you are developing, then it is very easy for us to select the material. And this material again interrelated to the properties of the physical as well as the mechanical properties. So that is why these are very important. Now high strength is an example may be achieved by expensive of low ductility. Here the strengths, the mechanical properties, whatever the properties you are seeing, the strength, the ductility, all this can be improved. How can we improve? Means depending upon your application. So based upon the selection of material, this is very important. Selection of material is very important. So which best material is selected for the required application based on your applications. So in some cases, high amount of load may be applied. If you see the bridges, so what happens? Continuous, there is a load. All the vehicles will pass. So what is happening here? There is a continuous load which is going on the bridge. So this bridge has to resist the continuous load which is forming. So depending upon the type of load and what is the maximum amount of load it can be withstand, you have to design your structure in such a way that the material is playing a key role there. So that's why the material is very important. So what type of load you are being. So that is the one thing. And next, any material, suppose a hot liquid, if you want to store in a flask, so what type of material you have to select. And this hot fluid has to be sustained up to some 5 to 6 hours. So like this, if you know the exact application, then only you can select the material. Selection of material, the selection of best material is very important, and this selection of material depends upon the main thing is what the properties of the material. So once if you know the properties exactly, then it's very easy for us to select the material. And the engineers design the part and the perform with a given range of properties. So for anything there is a maximum and minimum duration. Okay, the load varying. So maximum, this is the maximum load the material can withstand. So this has to given. So depending upon that maximum load only we are designing. So if you cross that load, what happens? There is a failure of the material. So that's why if you see any things, there is some expiry date for everything. So that means after this time there can be a failure. That's why you have to stop at that. So depending upon the maximum limit, the engineers are designing the exact frames or whatever the bridges we are constructing. All this depends upon the load bearing. So that is the important. Now, what are the main properties which can influence the materials? Okay, so some of the common mechanical as well as the physical properties which has to be taken consideration while designing any type of structure or any type of material which is related to mechanical, civil or aerospace. So this material science is not restricted to only the mechanical engineering. So it is all types of groups are being coming into this. So it is a multidisciplinary area. So where even the computers or the electrical or aerospace or mechanical, civil, everything, the materials plays an important role. So selection of material in any type of application. So this is very important. So how we are selecting is based upon the properties. So what are the important properties we have to identify or we are discussing which related to the selection of material is? First one is the conductivity. Second is the corrosion resistance, density. The fourth one is the ductility or the malleability. Fifth one is elasticity or stiffness. Sixth is the fracture toughness, hardness, of course the plasticity, strength, that is nothing but in terms of fatigue, coming to the shear, tensile and yield. The last one, toughness and wear resistance. So these are some of the important parameters or some of the important properties which we have to take into consideration while designing any type of structure which is related to any type of engineering. All these properties has to be taken into consideration. Then only one can design or one can construct, okay, a good output. So what is conductivity? So how to define these conductivity? So how much energy is penetrating into the body? Okay, how much amount of energy is penetrating into the body? So here the energy is nothing but the heat. Okay, so how much amount of heat is or the energy which is penetrating inside the body? So this depends upon the conductivity. How much amount of energy is conducting into the material? So based upon the conduction, again you have to select the material. Okay, so depending upon the conductivity, so there again each material will have its own thermal conductivity. That means how much amount of energy it can take inside, absorb the body. Now, thermal conductivity is nothing but it's a measure of the quantity of heat which flows through the material. So depending upon the value of the thermal conductivity, again, so can you resist the heat or can you penetrate the heat into the material? So all this again depends upon the selection of material. So conduction is very, very important, which describes the amount of energy which is penetrated inside the body. And of course, it's a measure of degree per unit time, per unit cross-sectional area or per unit length. So this is how you will calculate how much of energy is penetrating into the body per degree or per unit length or per square meter. So like that you will try to identify and you will calculate how much of energy is penetrating inside the body. And what is happening, what this conductivity refers. So if you have the amount of thermal conductivity as low, what happens? So any type of materials which are having less thermal conductivity, these are used as an insulator. So what are the insulators we are seeing? Like for the copper wires, we have some insulations, and for the thermal flash, we have insulations, or the hot packs, we have insulations. So what is happening here? Why we are generating or why we are keeping those insulators? Because we try to restrict or we try to avoid the heat escaping outside. Okay, we are trying to restrict the heat which is flowing outside. So these are all the insulators which are trying to use in the different applications based upon the value of thermal conductivity. That's why if the value of the thermal conductivity is low, these types of materials are used as an insulators, okay, for the application. And those, the other vice versa exactly, which is having the high value of thermal conductivity, these can be used as zinc. So if you see the figure, you can see easily the red area which is having the high penetration of heat. That means heat is being conducted inside very quickly, which is having the value of high value of thermal conductivity. In other way, the blue things, if you see, it is having less value of thermal conductivity. So depending upon the value of thermal conductivity, again you are selecting the type of material. So if you have higher value of thermal conductivity and if you are using as an insulator, so what is the use? So there is no use. That whatever the energy is there, it comes out. So if you see in the hot flask, if I pour the hot fluid and if I keep for 1-2 hours without having a proper insulator, so what happens? Slowly within 1 hour, again this hot liquid will convert into cold liquid. Why? Because we are not selecting the proper material as an insulator to that hot flask. Similarly, the electrical wires what we are using, if you are not giving a proper insulator to the electrical wire, copper wires, what happens? Whatever the heat is there inside, it will come out. So that's why the insulation materials are very, very important in the penetration of heat during the heat. That's why the conductivity values are very, very important. So that's why the thermal conductivity is the amount of energy which is penetrated inside the body. So that is how you have to calculate. Now again, if the value is very, very less, then these types of materials are used as an insulators. So that is how you have to apply the materials depending upon your application. So some of the examples we have seen. Again, the metals that exhibit high thermal conductivity would be considered for the use of applications like heat exchangers or refrigerators. Now, some of the metals have the higher values of thermal conductivity. So these metals which are having higher values of thermal conductivity can be used as in heat exchangers as well as the refrigerators. Like that, the metals or the plastics or the polymers, different types of materials will have the values of thermal conductivity. So depending upon the whether it is a metal or non-metal, okay, depending upon those types of materials, we are trying to use those applications. Like in the previous case, we have used insulators. If you see the figure, so in this figure also you have the insulators for the electrical wires, which is having the low thermal conductivity value. And again, if you see the next point, low thermal conductivity materials can be used in high temperature applications. Again, in high temperature applications, like what we have discussed in the previous slides, which is having high values of temperature applications like hot fluid which has to be stored for 2 to 3 hours. So there also you can use the low thermal conductivity values of materials. And but exactly opposite, often the high temperature components require, of course, the high thermal conductivity. So that is depending upon the type of climatic conditions we are using. And electrical conductivity, which is similar to the heat. So there is nothing much difference. There is an electrical enhancement or electrical penetration and heat penetration, depending upon the type of energy we are penetrating inside the body. If it is a heat conduction, electrical conductivity. So depending upon the type of application or type of energy we are using, we can use these types of insulators. And corrosion resistance. Again, so every body is exposed to different climatic conditions or different chemical compositions during the working process of any type of product. What is happening? So all these metals are exposing, even the humans are also exposing. So because of these exposure to different climatic conditions, what is happening? There is a formation of some scale. So okay, so because of these formations of different scales or different chemical reactions, what is happening? There is a formation of corrosion. So if you, corrosion is nothing but it disturbs the complete body. I mean, it will try to give the failure. Corrosion, if the value of the corrosion increases, what happens? Slowly the metal will get into the failure. That's why, because of these natural chemical exposure to the environment, so what is happening? Slowly the metal will be having the corrosion. So we have to prevent these corrosion. So corrosion resistance. So you have to avoid the materials to get corrosed. So what we have to do? We try to give some coatings with painting so that the life of the metal can be improved. Okay, so we try to reduce the value of corrosion. So all the materials will have some corrosion. If you keep the ferrous materials inside the liquid, what happens? Slowly it will start corrosion. And the same material which is exposed to different climatic conditions, so in cold or hot climatic conditions, slowly after 1-2 years, slowly there is a formation of rust. Okay, so this rust slowly converts into the failure. So if you see compare the early material which is not having any corrosion with after 2 years with corrosion, if you compare the strength wise, so there is a weakness which is higher in the corrosion material with non-corrosion material. So this is how you have to prevent the corrosion by giving some external coating onto the material, so that though there is a different climatic conditions or different chemical reactions which is covered onside the body, this can be controlled. So this is how you have to control the corrosion for the any type of material. That's why the lifetime which has to be increased by giving some of the, if you see here, 2 different types of materials you have. The silver one, if you see, it is a clean, which is doesn't have the corrosion. If you see the other portion, you have the full of corrosion. There is a rust formation. Now if you compare these two, what happens? The lifespan of that rusted or the corrosive material will be very, very less when you compare with the without corrosion. So how to control these means by giving some coating, plating or coating. So this will try to avoid the corrosion of the metal. So these are the how to improve the life. So we have seen the previous how to select the material, And in this case, corrosion, how to improve the material, we are seeing by giving some coating. So how to avoid those corrosions of the material. So that is another point. Next is density. Density is nothing but the how the atoms inside the metal are being packed inside the material. Okay, so weight will give the density of the material. So what is happening here? The density of the alloy will determine how much component of a certain size will weigh. Suppose I have two different blocks. If you see in this example, same block, same cube size I have. Now if you see here, the low density and high density, how the atoms are closely arranged. So in the same cube, if you see the high density side, I have a large number of cubes or the balls which are inside the cube. And if you see the low density, I have very less atoms which are arranged. Okay, so how the density, how the packing of each atom inside the material. So if you have a less spacing, then it is having a higher density. If I have huge distance between the two atoms, then it is a low density. Now nowadays, of course, because of the low density, what is happening? We'll get a less weight. But in the same way, nowadays we are trying to generate the materials which is having a lesser weight, but the strength has to be increased. So depending upon the property, you can select the low density, of course. But when you compare the strength wise with the low density and higher density may have the good strength properties when you compare with the low density. So that's why the low density, though you're selecting a low density value, material type of things, you can add some other material to improve the strength or the mechanical property. So that is how you can try to generate different types of materials with the help of these composites. So that's why all these things has to be considered. Whatever the properties we are discussing now, whether it's a conductivity or the strength wise or the density or the corrosion. So every type of properties matters when selecting any type of material. Coming to the ductility. So ductility is the ability of the material to deform plastically. That means it can be, so I want to stretch any material. So it has to be stretched without breaking. So that is the property of ductility. So it can be different shapes, I can deform it, but without breaking. So that is the thing which comes under ductility. So any type of product, if you want to design, okay, so when you're trying to generate the given raw material into different geometries without failure, if you're trying to achieve, then that type of material is called as a ductility. You can do any different shapes without breaking or without fracturing. And what is happening? And again, retain the new shape when the load is removed. So that is the property of the material. So in some applications, we need to try to bend or we need to get different types of geometries without fracturing. So if you are doing different operations, different machining operations, so during these machining operations, what is happening? The size has to be, or the geometry has to be changed. So during this change of the geometry, if the material does not failure, then that type of material is called as a ductile. So the material which have the good ductile properties can be molded into different types of shapes. So the ability of to stretch a given metal into wire. So how these wires are being developed? I have a 10 mm of diameter, a huge metal wire. So through this, I want to generate a 1 mm or 0.5 mm wire has to be drawn. So how we are getting? Because of the ductility nature of the material. Because of the ductility nature of the material, we are trying to get these 0.5 or 1 mm dia wires can be drawn. The same way, if the material doesn't have the ductility property, what happens? Though we are trying to generate these 0.5 or 1 mm wires, it will break at some point of time. So that is why you have to select a wire drawing, or if you have to, while preparing or while generating these wires, you have to select a material which has a good ductility property. So that is the importance of these ductility. And of course, ductility is often measured as a tensile test, as a percentage of elongation. So how it is being elongated? So since we are drawing a wire through a 10 mm or some huge diameter, from that huge diameter you're getting a small diameter. So what is happening here? We're trying to calculate how much percentage of elongation along the length as well as the percentage of reduction in the diameter we have to calculate. So if you calculate these two terms, then it is very easy for us to find out the how much percentage of ductility of the given metal will have. So during this process, what is happening? There is a increase in the length as well as the decrease in the diameter of the ductility. So this is how you have to calculate. And a tensile test can also be used to determine the Young's modulus or the modulus of elasticity, which is important, which plays an important role as a stress-strain ratio. So how to calculate the strength depending upon these values can be done by the tensile test, which is called as the Young's modulus. And of course, the tendency of the material to resist cracking or breaking under stress makes ductile properties. So during the process, what is happening? During any type of machining process, what is happening? The material has to resist from cracking or breaking, is it not? While you're drawing the wire from the 10 mm to 1 mm, so during this process, what happens? The material does not crack. If it is cracking, again, the material property doesn't have the ductility. So all these things has to be taken into consideration. Either the scratching of the material or the cracking of the material. All this has to be avoided. So then only that material has to be ductile. And the other process like cold working process also tend to make the metal less ductile. So during the hot working process, you can have a good value of ductility, but during the cold working process, some of the properties like ductility may come down because of the different climatic conditions. Hot working process, during the hot working process, we are doing the hot working process at the recrystallization temperature, but during this cold working process, you are doing very less temperature. So that's why the property of ductility may come down. And malleability, again a physical property which describes the metal ability to be formed without breaking. So if you see the picture 1, you can twist the metal into any different shapes. It is molding into different shapes, but there is no crack or there is no break of the material. So that characteristics is called as a malleability. So in the previous case, ductility, there is no chances of breaking of the material. And this case also the malleability also can be formed into different shapes, but there is no breaking. And again, pressure and compressive stresses can be used in these cases to find out the value of ductility. So there we are trying to use the tensile properties in the ductility. In this case of malleability, we are using the compressive test. So exactly opposite to that. There we are using tensile, here compressive. So compressive means two sides of loads which is coming opposite directions, same side. So that is called as a compressive. And a metal with high malleability will be able to withstand with high pressures without breaking. So though you are giving high amount of pressure on the material, okay, what happens? It will resist without breaking. So in any applications, if a high pressure or high load is acting, like what we discussed, the construction of the railway bridges or the dams, so there is a high amount of pressure which is involved. So there we have to select a material which is having a good malleability property. So in such a way that you have to select the material depending upon your application. So as we discussed, so this is having a good malleability. That means when a high amount of load or pressure is acting on the material, it may bend but it will not break. So there you can select the material which is having these types of properties. Next comes the elasticity of the stiffness. Elasticity describes the material tendency to return its original shape and the shape when a discharging force is removed. Now, what is happening? Elasticity, it is nothing but like a rubber band. If you apply a force on the rubber band, if you pull from both the ends, what happens? It will stretch. And again, if you release, what happens? It comes to its original shape. So that property is called as elastic property. So you are applying a load, it will stretch. When you release the load, again it will regain its original shape. So that type of system is called as elasticity. So this is the property of the elasticity. And as opposed to material that exhibits plasticity, plasticity is nothing but after elastic property, next plasticity will come. That means it will stretch and it will break. So that is the difference between the elasticity as well as the plasticity. Plasticity will break, but elasticity will regain its original shape after removing the original force. The stiffness of material is often measured by the Young's modulus. So that like that, different values of the stiffness or the toughness or the ductility, malleability will be calculated by the help of Young's modulus or compressive strength or the tensile strength. So depending upon the type of applications, we are finding out these types of values based upon the value of the Young's modulus or plasticity or the different values. We can identify the toughness or the stiffness of the material. Now, if you see here the higher values of modulus of elasticity, that means there is a great chances of having these values. If you see the comparison of spring, once you pull down the spring, what is happening again? If you remove the force, it will come back. So that is the example of this elasticity or well as the stiffness. Next, fracture toughness. So impact resistance is measured of a material's ability to withstand a shock. Now, sudden shocks when you give, that means sudden force or the vibrations or the impact on the body, suddenly it will come, it has to resist your body. That's why without fracturing, the material has to withstand. That's why it is fracture toughness. Okay, if there is sudden impact or the sudden force which is applied on the material, it has to withstand, or it has the ability to withstand without a shock. Then that type of things are called as a fracture toughness. So the effect of impact, a collision that occurs in a short period of time, that is very quick time when you give an impact on the any type of structure. So there is sudden impact of load. So during this sudden impact of load, the metal has to withstand itself without having this shock. So then that type of things are called as a good fracture toughness material. So impact resistance should be included when the application includes an elevated risk of impact. So wherever there is a chance of heavy risk of impact forces which are applied in the mineral exploration areas where you have a high explosions. So what is happening? Sudden force is coming onto the body. So during these cases, the metal has to be selected in such a way that it has to resist those resistance which is coming suddenly for a short interval of time. This is not for a long interval of time. Very small, very quick time. In the quick time, the metal has to withstand. So for those types of areas, we have to select a material which will have the ability to withstand from shocks. Certain metal may perform acceptably under static load, but fail under dynamic load. So what is happening here? Again, the load, what type of load you have, static or dynamic load. So static load, maybe some metal can be withstand, but dynamic load, so what is happening? They may fail you. So depending upon the type of load also you have to select. Not only the static or dynamic, uniformly load, the time interval, everything you have to select everything you have to take into consideration while selecting the material. That's why in this case, what is happening? Static load may fail, but the dynamic, static means sudden load. Dynamic means slowly, some continuous flow of load. If it is coming, it can withstand. So there is a different types of loads also we have to consider while designing or while selecting any type of materials. Again, the hardness. So what is the hardness here? The hardness is defined as a material's ability to resist permanent indentation, the plastic deformation. So any material, okay, when you give a high load, it has to resist from the permanent indentation, that is from the plastic deformation, that is the failure of the material. Okay, it has to resist when that type of material is called very good hardness. So the hard materials, the better resist wear or deformation. Okay, so if you have the high hardened material, what happens? There is a less chances of deformation or a less chances of failure of the material. The term hardness also refers to the local surface stiffness of materials or its resistance to scratch, abrasion or cutting. So during the machining process like scratching, abrasion or cutting process, what happens? Slowly, if you try to, during the cutting process, because of these vibrations or the load which is applied, so slowly what happens? It will turn to other part of the material and slowly it will turn to wear. So all these things it has to resist, then the type of materials are called as a hard materials. So these hard is measured by employing such a method of brittle hardness, weaker hardness. So like that, different types of tests are there to find out the values of the hardness, ductility, malleability, the corrosion resistance, the stiffness, everything can be calculated by the help of different types of tests. So like this, in this also, the hardness test also can be achieved with the help of the Rockwell hardness test. And if you see this chart, you have different types of hardness value, how it is being increased. So if you see the left side, you have the scale, the range from 1 to 10. So slowly, if you see the gypsum is having very less calcite, fluorite, apatite, and if you see the diamond is having the high value of the hardness. Okay, so while doing any machining operations, the cutting tool has to be selected in such a way that it is having the high hardness value. That's why if you see in any type of manufacturing industry, the cutting tools, what are the cutting tools we have? So most of the materials will have the diamond tipped cutting tools, so that the hardness is, because of the value of the hardness is very very high, so it can cut any type of material using these diamond tipped cutting tools. So this is how you can select. In the same way, if you see the right side, the common objects, again from the fingernails, the values of the strength will slowly increase. From the coin, next the knife, glass plate, steel line, and coming to the drill bit. So this is how the strengths, if you see the hardness for the common objects, while coming to the mineral names. Okay, so if you compare these two, the hardness value will increases. So depending upon the type of application, you have to select the what type of metal is useful to that application. Okay. Next, coming to the plasticity, this is nothing but the opposite of the elasticity, which describes the tendency of the certain solid material to hold into new shape when subjected to forming. So the plasticity is nothing but after the elasticity, what is happening? Elasticity is nothing but when you apply a force, it will deform, and if you release the force, again it will come to its original shape. That is about the elasticity. Now coming to the plasticity, what is happening? If you apply some force, so what is happening? It will deform its shape, and if you release the force also, it will be in the deformed shape only. It will not regain its original shape. So that is the difference between the plasticity as well as the elasticity. So during this forming process or during any manufacturing process, what is happening? Any material which is having a high plasticity value, it will deform into its shape, different shapes according to the force which you are applying, but it will not regain its original shape. So that is the description of your plasticity, and it is the quantity that allows the material to bend or work into permanent new shapes. If you want to perform permanent new types of different geometries, then we have to select a material which is having a good plasticity property. And materials transition from elasticity behavior to the plastic at the yield point. So at the yield point only, you will get the transformation of the materials or the metals from the elasticity to plasticity after reaching that yield point only. So after reaching that yield point, so before that yield point, you have the elastic zone. So elastic zone again is nothing but it will regain its shape. From after crossing that yield point, slowly this elasticity will convert into plasticity, where the complete deformation will occur. And coming to the strength wise, you have the fatigue. Again, the fatigue can lead to the fracture under repeated or fluctuating stresses. So if you continuously giving the forces on any type of material, what is happening? Slowly there is some distractions or the fracture inside the material. So this is because of the continuous load which you are applying. Okay, so this is about the fatigue in terms of strength. So if any body which is having a continuous load, so it tried to get some fracture inside. So that have the maximum value less than the tensile strength of the material, and higher stresses will accelerate the time to failure. Is it not? So continuous stresses which are giving continuously on any type of structure, what is happening? Slowly the metal will get failure after some time interval of time. And fatigue limit that refers to the maximum stress the metal can withstand. So how much amount of load can a metal can withstand will give the fatigue limit. The fatigue is nothing but the continuous load which is applied on the body, repeated load, and up to what time of interval this load can bear, so that gives the fatigue. And conversely, the fatigue life measures the load fixed and measures how load cycles of the metal. So if in some cases there is a continuous load which is being flown onto the body, that means like in a flyover or a bridge, if you take, there is a continuous repeated load. So because of these continuous repeated load, there is some disturbance in the material. So up to what limit these continuous load can be withstand will describe the fatigue. So fatigue limit is nothing but which refers to the maximum stress that metal can hold without fracturing. So this is the area where there is a continuous load is playing in. So there you have to select a material which is having a good fatigue value. Now in terms of shear, if you see, shear strength is consideration in application like bolts or the beam. So when you apply the high pressure during the bolt tightening or the beams, what is happening? You're giving a high amount of load. So there is a shear load is applied on the body. So up to what point this shear load can be resist during the working process will be described by the shear strength. So shear occurs when directional force causes the internal structure of the metal to slide against itself at the granular level. So like that, there is continuous directional force. If you are giving for the screw or the bolts, if you are tightening, then whether at what time of interval it can withstand, that will give about the strength of the shear. Again, the tensile strength. Tensile strength is nothing but the elongation of the material. So if you pull the material from both the ends to the opposite directions, what is happening? There is a tensile strength. So at what point, okay, the material can be withstand without breaking. So if you continuously pull the material, what happens? At some point it may break. So what is the maximum limit up to which this tensile force can withstand? Okay, so the rope bridge, if you see, if you act a point to what is happening, slowly it will expand. Is it not? So this expandation or the tensile force which is applied on the body, and what is the maximum point it can withstand, you have to take into consideration while designing anything. So it reaches to the point of permanent or plastic deformation. So this is also calculated by the help of the yield point. Now at the tensile point, the load causes the metal to ultimate fracture. So after reaching that limit, what happens? Slowly it get fracture. So like that, you have to find out the tensile properties of the material. So what is the maximum tensile property of the material? You have to calculate with the help of the ultimate tensile strength value. So depending upon that value, you will design your structure in such a way that this is the maximum limit where the metal can be tensile to this point. And coming to the yield, similarly, again, this is related to the tensile strength and yield strength only. So these combinedly describes the what type of yield strength the material will have. The deformation moves from elastic to plastic. Again, the transformation, how the material is converting. Every material will have the transformation from elastic to plastic. So that means the failure of the material. So what is the maximum value of the material which can withstand up to the elastic limit? Again, this is calculated with the help of the yield point to understand the limits of dimension under load. Okay, so different types of load are applied on the body, and if you will calculate what is the maximum limit of the yield point, so that it will convert from the elastic to plastic. So that is one of the criteria to consider while designing any type of product. And the toughness is measured using the choppy impact test. This is similar to the impact resistance. Again, how the body can be resist to its when some load is acting on the body, or different types of heat is or the energy is involved inside the body. So that is how you can calculate with the help of the choppy test. So these are all the different types of properties you have to know, and also how to calculate these values, and depending upon these values, how to design your structure. Everything matters. Okay. So generally, the choppy values are commonly prescribed in ferrous alloys where possibility of low temperatures exists. So this is applicable only for the ferrous, for not the non-ferrous alloys. Okay, for the ferrous types of applications only, we are using these types of choppy tests in order to find out the toughness of the given material. And of course, some of the examples where you can use these types of these things, ballistic containment in military or aircraft applications, you can use these types of materials where you have the high toughness values for the ferrous types of alloys. And wear resistance. So wear resistance is the measure of the material's ability to withstand the effect of two materials rubbing against each other. So when you have the two different types of materials which are rubbing with each other, there is some wear, that means the cracks which is forming due to the amount of the friction. Okay, so there is a continuous contact between the two different types of materials or two materials So what is happening? There is a continuous rubbing. So because of the rubbing, what is happening? Heat is generated. There is some chance of friction. So because of this heat generation or the rubbing between the two metals, there is some formation of cracks. So this can be taken from the adhesion or abrasion or scratching. So all these things comes under again the two different materials which rub against each other. So again, this has to be avoided with the help of some lubrications. So this is how to calculate as well as how to avoid or how to prevent the material we are discussing. So wear resistance may also be measured as an amount of mass lost for a given number of abrasion cycles. So continuous rubbing between the two metals, what is happening? It will try to give the amount of the maximum value where the metal can be withstand, though you can use the lubrication. So that is how you can calculate the wear resistance. Now if you see the complete summary of this session, so what is happening here? Considering this information about the mechanical and physical properties can promote an optimized metal selection for a given application. So if you know all these parameters, the physical as well as the mechanical properties of any given material, if you want to get the optimized material, the exact material, you can easily select if you know all these types of applications. So these are the major applications what we have discussed. Any material will have these types of things. Based upon these applications only, it is very easy for us to find out the exact material. That's why the optimized metal selection can be done if you know these physical as well as the mechanical properties. And because of the multitude of materials available, so you have an n number of materials, because there is a lot of exploration of the materials, and the ability to modify the properties through alloying also can be done with the help of the heat treatment process. And also it can be time well spent to consult the metallurgy experts to select the materials that provide the need performance balance with cost effectiveness. So the availability of materials is very high, and the selection of exact material depending upon your application. Though if you are not having the required material, you can improve the material by giving some other material as a heat treatment process. Through the help of heat treatment process, you can improve the properties, you can enhance the properties if you know the basic properties of the material. So this is how you can it will be helpful. All these things will be helpful for designing any product or designing any construction or designing any aircraft or any type of engineering. This material selection is very important. So if you know all these things, the physical as well as the mechanical properties, then it is very easy for us to get the optimized selection of material for the given application, as well as to, if you want to improve the properties of the any type of material, you can use this heat treatment process. And also you can consult some of the experts of the metallurgical team, and you can try to bring out some new metals with the low cost effectiveness. So this is how you can get from the information. Again, if you see the references, you can have the Sydney Havner Introduction to Physical Metallurgy, and the Essential of Metal Science Engineering by Donald, and the third one is Material Science Engineering by Kodagiri, and fourth one is Material Science Engineering by William Castle. So these are the 4 references books where you can get the information about the different types of properties, not only the properties what we have discussed. Rather than these properties, some properties are also discussed in these references, which will help to identify the optimized material for the given application, as well as how to know the different melting as well as the boiling points of the material, where you can reach the recrystallization temperature, and you can change the different properties based upon the heat treatment process. You can learn from these references books. Thank you for the session.
Like, share and subscribe. Hit the bell icon for more updates.